All right, I'm going to do a quick review of those couple problems that we missed out on yesterday. Starting with this one, I asked you guys to look at number 5. Okay, so if you guys pay attention to the language in number 5, it says, is there guaranteed to be a time t in the interval from 2 to 4 such that v prime of t equals negative 3 halves feet per second squared? Justify your answer. Okay, so a couple little tips on this is that anytime you see that such that, is there guaranteed, must there be, does there exist? Those are all those theorem speak type questions. And so we're gonna, first of all, once you see the mention of a derivative, you're immediately going to state that whatever function whose derivative you're talking about, that function is continuous and differentiable. So we will start with this. We have to begin by saying that v of t is continuous and differentiable. Okay, now there's two things. Yesterday we looked at Rolle's theorem, where we had two values being the same, and so the derivative had to be 0. If they're talking about the derivative being anything besides 0, and here it's supposed to be a negative 3 halves, all you need to do is like a slope situation. So I'm looking from 2 to 4. So I'm going to now say that, and I'm going to do a slope thing. I'm going to do y2 minus y1 over x2 minus x1. So v of 4, excuse me, minus v of 2 over 4 minus 2. Excuse me, I'm sorry guys, is equal to v of 4, what did we say that was yesterday? We said it was a 6, and v of 2 is a 9 over 4 minus 2. And that does give me negative 3 halves, and then I'm just going to restate what they say. So we will say something to the effect that yes, there is guaranteed a time between 2 and 4 such that v prime of t equals negative 3 halves. So, all right, so that's it, what you have to do on these theorem questions. So if it talks about a derivative whatsoever, you have to state that the function is continuous and differentiable. Okay, and if it's not a value of 0, then you're doing just a slope formula. So y2 minus y1 over x2 minus x1 on the given interval, which is from 2 to 4. And then you just restate their hypothesis, and that's all you've got here. Okay? All right, let's move on to example 3. All right, I apologize for this being blurry, but I know that you guys have a good copy of it. So we've got a particle moving along the x-axis so that its position given by x of t. And for number 1, it's asking if the particle is moving to the right or to the left. Okay, and I'm hoping that at this point we have a thorough understanding that the only way to understand if you're moving right or left is to look at the sign of the velocity function. So I'm going to take a derivative because I'm given x. I want to know what its derivative is. I don't know, I wrote v prime. V is x prime, and that's just a simple 3t squared minus 12t plus 9. Okay. And in this particular case, I don't have to find zeros on this. I just want to know what's happening at specifically time 0. So v of 0 would be 3 times 0 squared minus 12 times 0 plus 9, which is 9. I don't care that it's 9. What I care about is that it's positive. Okay, so I'm going to state that it's positive. That's a really big deal. Okay, I'm going to do it very simply. I'm going to say it's greater than 0. If you want to say v of 0 is positive and you want to use the words, you can do that. But now I can say, therefore, I'm moving, because my velocity is positive, I'm moving to the right. Okay? Okay. For question number 2, it says at time 1, is the velocity of the particle increasing or decreasing, and explain your answer. Now, I don't want you guys to get super into the physics, the motion, the rules, whatever. Use your basic knowledge of calculus. Okay, so we're talking about, is this function, is a velocity function increasing or decreasing? How do I tell if any function is increasing or decreasing? Well, I look at the sign of its derivative. If velocity is increasing, its derivative will be positive. If velocity is decreasing, its derivative will be negative. So I'm going to find the derivative of velocity. Some of you guys already have made this connection where, oh, that's acceleration. So if I want to know if velocity is increasing or decreasing, I'm going to look at acceleration. If you're not making that connection yet, that's fine. Rely on the basis of calculus. Okay, and the basis of calculus is that I know a function is increasing if its derivative is positive. I know a function is decreasing if its derivative is negative. So I'm going to take the derivative velocity. Here's my velocity function. So the derivative is 6t minus 12. Okay, and I want to know about it at time 1. So all I'm going to do is find v prime of 1, and I'll get 6 minus 12, which again, I don't care about the value. I know that it's less than 0. Okay, now if a function's derivative is less than 0, that means that my function is decreasing. So therefore, velocity is decreasing. Okay? All right. Yep, we're going to do the next one here. All right, if we consider number 3 now, for number 3, I want to know when the particle is moving to the left. So again, I got to go back to my velocity function, which we found before. My velocity function was 3t squared minus 12t plus 9, and I want to know when my particle is moving left, which means my velocity has to be negative. All right, so I'm going to now go ahead and factor this. I'll factor out the 3 first, and then I'll finish the factorization. I'll have a t minus 3 times a t minus 1 equals 0. So that's going to equal 0, t equals 1, and t equals 3. I'm going to make myself a little sign chart. Now, I don't have, it doesn't give me any restrictions on my time values, so I'm just going to go and look at a sign chart and check the signs of my velocity. Here's where my velocities are 0. If I look at a value before 1, let's say like a 0, I'll have a positive times a negative times a negative. 2 negatives makes it positive. Okay, if I pick a number in here like a 2, I'll have a positive times a negative times a positive. 1 negative keeps it negative. Okay, and then for greater than 3, I'll have positive, positive, positive. Everything is positive. So I'm moving left when my derivative is negative. I'm sorry, when my velocity is negative. Okay, which is the derivative of my position function. So I'm moving left on the interval from 1 to 3. Okay, I'm not going to include 1 or 3 because I am not moving at all at time 1 or time 3. Think about why. Why am I not moving at all at time 1 or time 3? The answer is because the velocity is 0 there. Okay, so that's why I had an open interval for when I'm moving left. Okay, hopefully that makes sense. Okay. Number 4 asks for total distance traveled, and we're going to approach our total distance traveled the same way that we did yesterday. And there are other ways to handle this, but right now this is what we're doing. So we're going to start with the fact that we realized this was our velocity chart, that I'm moving right before 1 and then left between 1 and 3 and then right again. So on the interval from 0 to 5, I want to figure out where do I start and then where am I at each time I change direction, and then where do I stop. So I need to know what x of 0 is, what x of 1 is, what x of 3 is, and what x of 5 is. Okay, so again, I'm looking at my position, x of t, at my starting value, my ending value, and each time I change direction. Okay, so that's why I chose those numbers. So go ahead, pause the video, figure out what those values are if you haven't already, and come back to me when you're ready. Okay, I think I have these numbers right. I'm not 100% sure because I'm a little brain dead today. So double check my math, but this is the situation. So I have my x-axis, right? Okay, at time 0, I'm over here at a position of 11 on the x-axis. Okay, and then I'm going to move, and at time 1, I'm at a position of 15 on the x-axis. So on that interval, I just traveled 4 units. Okay, now at time 3, I'm going to end up back at the same position. So I'm here at time 3 again. So that distance is another 4 units traveled. Okay, and then at the very end, I shoot off from time 3 up to time 5 and I end up at t equals 5, I end up with a position of 31, and that's another 20 units traveled. If I add all that up, it means I've traveled a total of 28 units, and that's my total distance traveled. And that's all.